All right, pre-calc group. Pre-calc group. Today we're looking at reciprocal functions, the first day. So reciprocal functions. We have three reciprocal functions. They are called secant, cosecant, cotangent. So that rounds out, we have 6 total trig functions. The word reciprocal functions, well, you'll see it here. The secant, SEC abbreviation for secant, is equal to 1 over the cosine. So secant of theta. So 1 over the cosine of theta. Cosecant, CSC. Cosecant theta is equal to 1 over the sine of theta. And cotangent of theta is equal to 1 over the tangent of theta. So with these reciprocal functions then, so now we have a grand total of 6. We pick up one more identity. Okay, remember tangent of theta is equal to sine of theta over the cosine of theta. Well, the reciprocal then means the cotangent of theta is equal to the cosine of theta over the sine of theta. Okay? Okay, what are we going to do with all this information? Well, we still have to remember our SOHCAHTOA. Okay, so if we know the sine of something and we want the cosecant, we just have to flip it over, do the reciprocal of it. Okay. Answering these questions, we have exact values, so 150 degrees, 330 degrees. We have to know our triangles. Remember our 30-60 triangle, so 1, 2, radical 3, and then the 45. 1, 1, radical 2. So if I have the sine of 30 degrees, 1 over 2. Okay, and then we can do all of our work from there. And then we need to know our unit circle. One, 0, 0, 1. So we have our 0, our 90, 180, 270. Okay? Remember, cosine, then the sine. All right. The unit circle is for the quadrantial angles, and then we have our specials, our 30, 60, and the 45 for our exact values. So this is old stuff right here. Here, this is new. These are new. All right, so how do I find the cosecant of 150 degrees? Well, we have to do all the work that we did in the last lesson when we found exact values. We need to know what the reference angle is. So we're going to draw the angle in standard position. 150 puts me here. We'll subtract from 180, and we get 30-degree reference angle. So we're going to do all of our work for 30 degrees. Cosecant is 1 over the sine. So whatever the sine of 30 degrees is, and then we'll flip the answer over. 30 degrees, sine is opposite over hypotenuse, so we're looking at 1 over 2. Now cosecant means the reciprocal of this answer, so that just becomes 2. And now the only thing I have to worry about is what quadrant we are in. And in quadrant 2, the y values are positive. Okay, so we're looking at an answer of 2. Remember, that was the ASTC. All students take calculus. All are positive, sine is positive, tangent's positive, cosine's positive. Okay. All right, cotangent of 330 degrees. Okay, cotangent. Cotangent means 1 over tangent. So we have to do all of our work for tangent, and then whatever that answer is, we flip over. So we're looking at tangent of whatever the reference angle is for 330. Well, hopefully you know that the reference angle is 30 degrees. Remember, draw your angle in standard position. And then here's your reference. Okay, so we have 30-degree reference angle. Okay, so now, tangent of 30. Well, here's 30 degrees. Remember, tangent, opposite, adjacent. Opposite over adjacent. So we're looking at 1 over radical 3. And we are in quadrant 4, tangent. The only function positive in 4 is the cosine. So this is a negative 1/3. Now I need to do the reciprocal. So I have to take this answer and I have to flip it over. So what happens when I flip this over? We have negative radical 3 over 1. Yeah, you know I don't have to say it over 1. So now we have the cotangent taken care of. All right, secant of 315. Secant, what are we thinking of? Well, secant is 1 over the cosine. So I need the cosine of the reference angle. 315, what is it? 45 degrees, very good. And in 315 is in quadrant what? There's 315 right there. So here's your reference angle, 45. And what do we know about cosine in this quadrant? 4. It's positive, so I know our answer is positive. All right, so 45 degrees. Adjacent hypotenuse. Cosine, adjacent over hypotenuse. 1 over radical 2. And then what do I have to do with this answer? We have to flip it. Reciprocal, radical 2. Problem's done. Okay? That's how we do those. I know I did that quick, but all they are, I mean, you did them last year, and then also, remember, if you can find your, if you know your reference angles, all you're doing is just taking that answer and flipping them over, and that's all that I did. Okay. All right. 2 pi. What's 2 pi? That's right, 360 degrees. So we're looking at the secant of 360 degrees. That is a reference. That is a quadrantial angle. All right, that's a quadrantial angle. That's 360. Well, here it is. There's one full circle, 360. Secant is cosine. So we're looking at, remember, so I put my C's and S's, X and the Y, cosine are the X's, sines are the Y's. So we're looking at the cosine of 360, which is 1, and now I have to do the reciprocal of 1. Well, 1. Done. All right. Cosecant of 2 pi. Well, cosecant now is 1 over the sine, is sine. There's the sine right there. That's 0. So the sine of theta, the sine of 360, or 2 pi, is 0. What happens when you flip that over? When we flip 0 over, it becomes 1 over 0, so that's our undefined. Okay, that's our undefined. All right, last one. Cotangent, 3 pi over 2. What's 3 pi over 2? Yes, you got it. That's 270 degrees. Okay? That's 270. That's your other quadrantial angle. What are their quadrantial angles? Remember, 0, 90, 180, 270, 360, going back to the 0. In terms of radian measures, this is degrees. In terms of radian measures, 0, pi over 2, pi, 3 pi over 2, 2 pi. Folks, all you're doing is counting by halves. A half, 1, 1 and 1/2, or 1.5 pi, and then 2. Okay? All right, so cotangent of 270 degrees. So that means we're looking at tangent of 270. All right, so remember, tangent is sine over the cosine. So that's 0, actually, I'm going to look right here. Cotangent, cotangent is sine over the cosine. So that's 0 on top over, negative 1 on top over 0. So all I have to do is take that answer and flip it over. So now we have 0 on top over a negative 1. So we have 0 over a negative 1, because that's our cosine over sine, and which gives us 0. So in other words, if you take an undefined and flip it over, you have 0. If you take 0 and you do the reciprocal, we have undefined. Okay, so I use my identities right there. Okay, from our ordered pairs. All right, how do we do the name the quadrant game? Doing the name the quadrant game. Now I'm going to do my little check marks. So I'll do a black check mark, and then I'll do a purple check mark. So secant, what do we say for secant? That's cosine. So whatever works for cosine works for secant. So here's my ASTC. So secant is greater than 0. Remember, you're thinking cosine. Okay? Think cosine. So that means secant is, we're thinking cos, we're looking for positive. Remember, we're checking marks the positives. So check and check. Sine of B is less than 0. That's negative. Well, where is the sign negative? Well, there and there. So here we have our double checks, quadrant 4. I'm going to do one more. So I'll use cosecant with the purple pen. I'll do cotangent with the black pen. And here's my ASTC. So cosecant, we think sine. Cotangent, think tan. Okay. So when is sine negative? Well, here and here. Remember, all our positive, sine is positive. Everything else, it's negative. Remember, the sine is your y values. Y's are negative under the x-axis. Cotangent is less than 0, is negative. So we're thinking tan. Where is tangent negative? Tangent's negative here and here. So again, we are in quadrant 4 for an answer. Okay. All right, last piece that we have to do. Nice little question here. Okay. It says angle theta is drawn in standard position on a unit circle. Unit circle, we know what that means. The terminal side passes through point P. Find all 6 trig functions. So because it's a unit circle, remember, what's the radius of the unit circle? The radius is equal to 1. Unit circle, radius equals 1. You don't need to draw a picture for this, because remember, in the first day of me teaching you the unit circle, the ordered pairs, when you have the ordered pairs given, remember, in a unit circle, the x-coordinate is the cosine, the y-coordinate is the sine. That's all you need to know. We can fill in all 6 pieces. So right now we know the sine is radical 6 over 4. We know the cosine is 5 radical 6 over 12. Okay? So now how do we do the tangent? Well, remember, the tangent comes from our identity that we have. Remember, that's the sine over cosine. Well, sine over cosine. I'm running out of room here. I think what I'm going to do is I'm going to do it over here. So I will do tangent over here. So tangent of theta is the sine, radical 6 over 4 over 5 radical 6 over 12. So we have a nice, beautiful, complex fraction. So I'm going to multiply by the common denominator to get that taken care of. So I'll multiply by 12. So that cancels out. So I have 5 radical 6. And then 4 goes into 12, 3. So I have 3 radical 6. And look at that. Radical 6 cancels out. So we have 3/5. Okay. So the tangent is 3/5. Now, I lined these up in a specific way. Look at what I did. Here's my sine. The reciprocal function is the cosecant. Here's cosine. The reciprocal is secant. Well, what's reciprocal mean? All we have to do is take this fraction and flip it over. So we're looking at 4 over radical 6. You guys are in pre-calculus. We don't have radical 6's in the denominator, so we have to multiply top and bottom by your radical 6. So we have 4 radical 6 over 6, so that reduces to 2 radical 6 over 3. Okay. All right, secant. Well, just taking this answer, flipping it over. So 12 over 5 radical 6. So again, multiply top and bottom by radical 6. So I have 12 radical 6 over 30, and we reduce. 6 goes into both of those, so I have 2 radical 6 over 5. All right, cotangent, 3/5. Oh, that just becomes 5/3. We're done. Okay. All right, now, I have to also worry about if those answers are positive or negative. Well, what do we know about the signs here? Everything's positive. That's quadrant 1. These are all positive answers. I noticed I didn't have any negatives in there. Okay? All right. I know I did that quick, but that's just how fast and easy this is. Let's look at the last one. Well, which one of these is the sine? Well, you're right. It's the y-coordinate. There's the sine. There's the cosine. So look at how easy, 4/5. There's no radicals in here to worry about. Okay? And then what's the tangent? Well, we already talked about that. That's the sine over cosine. So sine over cosine. So I'll do my work here. So 4/5 over a negative 3/5 and cancel out the 5. So we have 4 over negative 3, or negative 4/3. There. Negative 4/3. And then look how fast and easy it is now. No radicals to worry about. Again, all lined up perfectly. That's how I expect you to do it on your assignment. 5/4, negative 5/3, negative 3/4. That's how quick and easy it is to do this reciprocal functions work.